Artificial neural networks are one of the most popular and effective machine learning methods. Artificial neural networks mimic the work of the human brain, creating many interconnected nodes or neurons. These neurons process information and transmit it to other neurons. Artificial neural networks are used to solve various tasks such as pattern recognition, speaker recognition, natural language processing, and more. They can be used to create systems and can learn from data and make predictions based on the data. There are several types of artificial neural networks, including perceptions, recurrent neural networks, convolutional neural networks, and others. Each type of network has its advantages and disadvantages, and the choice of the network type depends on the task to be solved. Various algorithms are used to train an artificial neural network, such as reserve error propagation, the stochastic gradient descent method, and others. These algorithms allow the network to learn from dataset and improve its performance with each of-round training. In general, artificial neural networks are a powerful tool for solving many problems in the fields of machine learning and artificial intelligence. ANN is the abbreviation of artificial neural network, which has several layers. The first layer is the data input layer. This layer is responsible for receiving input data for the neural network. The input that can be presented in the form of text, image, audio, or other data types. The input layer of ANN is the level at which data enters the network for processing. At this level, the data is converted from the original format to a format that can be processed by ANN. This may include converting text to numbers, image to arrays of numbers, and etc. The input data is then transferred to the next level of data processing, where it is processed by artificial neurons. The second layer is data processing layer, or this layer is also called hidden layer. Data is processed using artificial neurons that perform mathematical operations to convert the input data into output. The hidden layer of artificial neural network is the layer between input and output levels. At this level, the main data processing takes place when the input data is converted to the output. At the hidden level, artificial neurons are used to perform mathematical operations on input data and transmit the results to the next level. The number of hidden layers and number of neurons in each layer can vary depending on the complexity of the task and the amount of data. The last layer is the data output layer. Data output layer, at this level, the ANN outputs the result of processing input data. The results can be in the form of numbers, text, image, or other formats. The output layer of ANN is the level at which results of data processing are output from the network. At this level, the output is usually numbers, text, or image, which are results of processing the input data at the hidden level. The output layer may also include optimization of neural networks parameters to improve its accuracy and reliability. A separate neuron is an ANN is the basic element that makes up a neural network. It performs mathematical operation on its input data, sums it up, and applies activating function to get output signal. Neurons are connected, and each neuron receives a signal from other neurons. Thus, a neural network can process complex functions and make a prediction based on a large amount of input data. A single neuron in ANN is a fundamental building block that mimics the structure and the function of a biological neuron. The main components of a single artificial neuron include inputs, weights, summation function, activation function, and biases. The last one is the output. Inputs neurons receive input signal from the other neurons or external sources. Each input associated with a weight, which represents the strength of importance of that input. Weights are associated with each input and determine the contribution of that input to the neuron output. During the training process, these weights are adjusted to optimize network's performance. Summation function. The weighted inputs are summed together. This process involves multiplying each input by its corresponding weight and then adding up these products. Mathematically, this can be represented as the dot product of the input vector and weight vector. Activation function. The sum of weighted inputs is then passed through the activation function. Activation function introduces nonlinearity to the model and determines the output to the neuron. Common activation functions include sigmoid function, hyperbolic function, and linear unit function. Bias. Bias term is added to weighted sum before passing through the activation function. Bias allows the neuron have some flexibility and adaptability. The output is the neuron is a result of applying activation function to weighted sum plus and the bias. This output is then passed to the next layer neurons or its final output of the network, depending on the neuron's position in the network architecture. These components work together to enable artificial neurons to process information and make predictions. In a complete neural network, neurons are organized into layers: input layer, hidden layer, and output layer, and the connection between neurons are determined by the weights. The training network involves adjusting weights and biases to minimize difference between the predicted output and the actual output for a given set of inputs. The activation function has an important role in the ANN calculation. The activation function is a mathematical function that introduces nonlinearity into the output neuron. The most known activation functions are binary step function, linear function, sigmoid or logistic activation function, ReLU function, Lickler ReLU function, parametric ReLU function, ALU function, softmax function, swish function, Galois function or Gaussian error linear function, hyperbolic tangent activation function.